Let's say I have, now listen to it very carefully, many people hear it wrong and they make mistakes. So let's say there is a stack and the name of this stack is S1. So this S1 is pointing to this particular stack. Okay, I want to revert this stack itself. This stack is to be reverted. By that what I mean, whatever memory location this is, now I want 3 2 1 over here to come. So I simply want the stack to be reversed at this particular memory location. Is there a way I can do it using two stacks? So by two stacks I mean, this is my one stack which is already there, and then let's say I take another stack and I call it temp1. So if you empty everything from here and push here, you'll get something like this, yes or no? You'll get this thing. Is it wise to say that, hey, now this is looking as reverted form of this, so I got my job done? Is it wise to say? No, because you did not revert it. You're supposed to revert this. How this looks, I do not care. This should look reverted form of its initial form. Okay, so what to do? Now you might be tempted to say that, hey, now again I'll push this back over here. So if you do reverse of reverse, you will get back what it is, yes or no? So that is not the right way to go ahead. Again, those of you who are thinking about queues, you have to do it using standard stack operations only. You cannot use any other data structures or any operation of any other data structure. You have to use the standard stack operations only. Okay. Can I say that if I manage to somehow get another stack where the elements are in the same order, look at me very carefully. If I manage to get another stack where somehow I am able to get the elements in the exact 1, 2, 3 order, now when I pop and push here, I'll get the reverted form. Okay, and what is the way to do that? The way to do that is, this was reverse and this is reverse of reverse. So when you empty this and put here, this and this, both of them are alike. Now what you can do is, now you can pour everything from here to here. So it's basically reverse of reverse of reverse of reverse. So what you will get will be reverse. So first you empty everything from here to here. So this is the reverted form of this. But now if you just pour in from here to here, you will get the original thing. So before doing that, you should pour in over here so that both of them are alike, and now revert it in this way. How much time complexity? A very frequently asked question in interview it is. So how much is the time complexity over here? It's order n, right? Yeah, because in almost order n you can get everything from here to here. Then again in order n almost from here to here, and then again from here to here. So 3 into n is around order of n. How many of you can do it using recursion? This is excellent question on recursion. Let's say you have something like this. This is your stack 1, 2, 3, 4. I want to revert it. So my target is to reach here. My target is to make this stack look like this, right? So what I'm going to do is, I'm going to do first thing as pop. So when I pop, I'll get this 4 out. Okay, so let's say I popped and I got this 4 out, and then let's say I somehow call a magical method reverse on the remaining stack. So my remaining stack is 1, 2, 3. Whenever I say magical method, you might be tempted to think that again this will be nothing but a recursive call. And now let's say this magical method works somehow and converts this into something like this, which is 3, 2, 1. Now when this is converted to 3 to 1, what should be the final step that I should do to ensure that it looks like 1, 2, 3, 4? What should I do with this and this in this step so that it looks like this? Insert bottom, push bottom. Yeah, so that is the thing over here. So unlike previous question where you were popping, calling recursively and then pushing, here instead of just pushing, you will push bottom whatever you have popped. So let us quickly analyze the recursion tree diagram here. So how is that going to look? Let's say you called reverse on a stack that looks like this. 1, 2, 3 and 4. Okay. So first thing that you will do is, what will you do first? You first call pop. And when you call pop, you will get this 4. Okay. After this, what will you do? You will call reverse on the remaining part of the stack. So reverse has been called on 1, 2 and 3. And once this is over, then you will perform a push bottom of whatever you had popped. Now again here, first you will call a pop. You will get 3, and now you will call reverse on 1, 2. And then finally you will push bottom whatever you have popped. Now again same thing here. You first call pop, you get this 2. You call reverse on this much part, and when this is over, then you call push bottom of whatever you have popped. Now again here, you first call pop, get this one, call reverse on empty stack, and then finally push bottom whatever you have popped. Should this be my termination condition? Yes or no? What should I do here? What is the physical significance of this? It is trying to revert an empty stack. Should I even do an operation for this where you are trying to revert an empty stack? No, empty stack is already reverted form of itself, right? So you will simply return here. You will simply return. So now the control goes to push bottom 1. So here you will have 1 coming over here. Now it will go to push bottom 2. So this 2 will come belong, and this push bottom is again that recursive function. So corresponding to all of them, a recursive tree is going to be forked. So now again, when you go above this, push bottom of 3, so it will push 3 here, and then push bottom of 4. I am not going to draw, you know what is going to happen. Now let us talk about the time complexity. All these operations which are pop, 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 these are order n, and there are n elements, so there will be n pops. Now let's talk about push bottom. How much time will first push bottom take? First push bottom, how much time is that going to take? Just 1. And how much time will second push bottom take? 2. Third push bottom? 3. Nth push bottom? N. So it will be sum of 1 to n. So what will be the complexity here? N square. So do you realize that this is less optimal approach than previous one? Yes or no? This is less optimal. Now think if you can make it a bit more optimal, okay? Using recursion, can you make it something like order n? Just think about this, not now, later, but I believe you should be able to quite easily do that. How the code is going to look like? So I'll have a reverse method, I'll have a stack coming here, and this will be a void. And what is my termination condition? My termination condition is if my stack dot empty, this thing is true, simply return. Otherwise, what to do? Pop the element, x is stack dot pop, and then call reverse on the remaining stack, and then finally call push bottom of x, and push bottom was already implemented.